Alright, hello everyone. Today we're talking about lesson 10.5. We're going to cover tangents. Here you can see our objectives. We'll use properties of tangents, and we'll solve some problems involving circumscribed polygons. So we're talking about tangents, so let's do the definition here. A tangent is a line, ray, or segment in the same plane as a circle that intersects the circle in exactly one point called the point of tangency. So here we have line AB. We've got line AB that is tangent to circle C. That means it intersects circle C at a single point. That point that it intersects the circle is actually point A, which we call, again, the point of tangency. Get another definition here. A common tangent. A common tangent is a line, ray, or segment that is tangent to two circles in the same plane. So common tangent would be a line. So here line L, it is tangent to circle G as well as circle F. So it is a common tangent. Here line L, again, common tangent to F and G. It intersects both there at that point. Tangency. Okay. So a good exercise here, I'm going to use the line tool here, would be, try to draw a couple of lines of tangency. And before I use the line tool, I'm actually going to use a ruler here and show you guys. So how you guys can kind of find some tangents if you're drawing tangents on a shape here. Way to do this. Sorry, I'll plug in a mouse here. Makes this easier. Alright, so one way to do this is to take a straight edge. It doesn't have to be a ruler, but just take a straight edge, and you'll kind of want to line it up and just try to find, so if you're trying to draw tangents, okay, just want to line it up as best you can so that it intersects only at a singular point on both lines. So that line that goes right through there, that appears to do so. That would be a line that is a common tangent of those two circles F and G. I could have drawn that line slightly better. It's me. There would be a good common tangent. We can do this again. Maybe this is easier with the lines. Just kind of adjust each end point here. So that is another common tangent. Of course, we could draw the one that would kind of be opposite to L and come through this other direction, maybe like that. All right, and you guys go ahead, pause, try to draw some common tangents here on this next example, or at least think of some if you're not drawing. Okay. Of course, you could have one that would through like this. Let's adjust a little bit. So that'd be a common tangent. Of course, you can go the other way. I think that'd be the only ones we could have there on F and G. So it's good practice to try that. On these next couple of examples, they want you to find some common tangents with both of these. All right. If no common tangents exist, state no common tangents. So this one you should be able to identify a couple on that first one, and then maybe 4 on the next one. So we're looking at A and B. So if we look at A first, a good common tangent here. Adjust a little bit. And we want it to touch both lines at a singular point. Both circles at a singular point, so getting closer. There. Appears to be tangent to both circles. And you could also go with this one along the bottom. Good start, but kind of adjust, of course. So there's 2 on A, and then B, really pretty similar to this example we see here. So you could have 4 on that circle B, or those 2 circles in example B. So let's get back to full screen here. In a plane, so theorem 10.10 has to do with tangents. So in a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So if we look at line L, it is tangent if and only if this radius drawn to the point of tangency, that point T, if that radius is perpendicular. And so line L is tangent to circle S because that radius is perpendicular. All right. So JL is a radius of circle J. So here we've got, let me get a pen, JL, the radius of circle J. Determine whether KL is tangent. So we want to know, is this segment KL tangent? So, and then we got to justify our answer. So what would make KL tangent? Well, it would be tangent if this angle is right, if they're perpendicular, if that radius is perpendicular. So we want to determine, is angle KLJ, is that 90 degrees? Is the measure of that angle 90 degrees? The way we can do that with these measurements that we're given, we can check to see, well, is this a right triangle? Is JKL a right triangle? And of course, to do that, we would just need to check and see if check the Pythagorean theorem. Is C squared equal to A squared plus B squared? If, of course, C is our hypotenuse, well, what would the hypotenuse of this right triangle be? Looks like this segment's 9. This other segment here would be 8 because it's also a radius. So the full hypotenuse we should be checking here would be 17. So is 17 squared equal to, the other two are just legs, 15 squared plus 8 squared? Well, let's see here. So 17 squared is 289. 189 equal to 225 plus 64. And these are equal. So what does that mean? Well, that means this is a right triangle. If this is a right triangle, then that is a right angle, and we can say KL is tangent to circle J. To answer the question. Okay, this is our justification. This is justifying our answer. Okay. So that's how you would do an example like that. You just check to see, is it a right triangle. All right. The next one wants us to find the value of x, use a tangent to find missing values. So JH is tangent. It's telling us it is tangent, so that tells us that GJ is perpendicular to JH. So this is a right triangle. Now, find the value of x. So what we want to do here, we want to set up, we'll use the Pythagorean theorem again to find x. So this is x plus 8. That's the hypotenuse. So x plus 8 hypotenuse squared equals leg squared. So one of the legs is x, the other leg is 12. So we're going to solve this equation for x. So recall x plus 8 squared, we've got to, binomial squared, we've got to actually FOIL that. So we'll do that in just a moment. That should equal x squared plus 144. If we FOIL over here, we get x times x squared. X times 8, it's 8x plus 8x plus 64. Okay. If we want to move all of our x's here to the left, the x squareds cancel on both sides. So that leaves us 16x plus 64 equals 144. Subtract 64 here. Gives us 16x equals 80. Come up here. Solve, divide by 16. gives you x is equal to 5. All right. I believe one on the homework, you've actually got to solve a quadratic, so kind of be aware of that. Here we did create a quadratic by using the Pythagorean theorem, but we didn't have to, solve the quadratic because the x squared is canceled out. I think one on the homework, you actually have to solve a quadratic, use the quadratic formula or factoring. So be aware of that. Quadratic formula, of course, so this is for the homework. We didn't have to use that here because the x squared is canceled, but on the homework, may need the quadratic formula. That's x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Or you can recall factoring, which that wouldn't be a bad idea either here as we prepare. I know many of us are preparing to take I-STEP. This is kind of an Algebra 1 concept. It's a good thing to review. Okay, actually, in fact, this is a good type of question for I-STEP. It kind of combines some geometry skills with some Algebra 1 skills. So be aware. So theorem 10.11, if two segments from the same exterior point are tangent to a circle, then they are congruent. So these two segments, BC and BA, are congruent. Okay. These segments are congruent because they come from the same exterior point and they are both tangent to circle D. So that would make them congruent. All right, and we can use this property, we can use this theorem, I should say, in some examples here. So AB and CB are congruent to tangent, AB and CB are tangent to circle D. Find the value of x. So we know that these two segments AB and BC, they are tangent. Well, if they're both tangent and come from the same point B, then AB is congruent to CB. And we can use that to come up with our equation. X plus 15 equals 2x minus 5. Just substitute A, B, and CB. Solving for x, 15 equals x minus 5. Add 5 to both sides, we get that 20 is equal to x. So that's a pretty simple type problem using this theorem. All right. And the next example, we'll use that same theorem, but here we're going to use it for polygons. So we're going to have a little bit of background knowledge here. A polygon is circumscribed about a circle if every side of the polygon is tangent to the circle. So this triangle, this quadrilateral, and this hexagon, they are all circumscribed, okay, because the sides are all tangent. They all intersect the circle at a singular point. All right, and you can see that in each of these polygons that they are circumscribed. Okay, all of these here are non-examples. They're not circumscribed because not all sides are tangent. In this quadrilateral, that side, it doesn't intersect the circle. Okay? None of the sides intersect in this hexagon. So these are all non-examples. They're not circumscribed. And so we'll find measures in circumscribed polygons. Quadrilateral RSTU is circumscribed about circle J. If the perimeter is 18 units, find x. So again, perimeter is just if we add all of the side lengths up. And it gives us perimeter. So perimeter is 18. So we want to use that to come up with some equation where we can solve x. So 18 equals, well, if we add all of the sides, so let's start here with side TS. Side TS is just x plus 3. That's the length of that. Okay. So that's one of our sides. We've got 4 more that we need to express. So what about side SR here? If we look at side SR, right, we know that SA is congruent to SD because they're both tangent and they come from the same exterior point. So that would tell me that's 3. So side SR would be 3 plus 3, which is 6. Okay. As we look over here to side UR, okay, again, we've got to use the same idea that RC, that segment, is congruent to RD, because again, they come from the same exterior point, and they're both tangent to the circle, so that makes them congruent, so they're both 3 there. That means the side then UR is x as well. So there we go. Alright, and now we just need to add that last side, TU. I'll use another color here. So how can we express TU? Well, TA and TB, both tangent, and come from the same exterior point, so they're congruent. So that would be X. BU and UC are both congruent as well, so they're X, so X plus X, side TB would be 2X. Alright, so if we solve this equation for X, then we would have solved the problem. So just combine like terms here. We got 18 equals X plus 2X. That's 4X. And then 3 plus 6 is 9, plus 3 is 12. And so we subtract 12 here and get that 6 is equal to 4X. Divide by 4, 6 over 4, it would reduce to 3 over 2 equals X, or 1.5 if you use the decimal. All right, so that wraps up these notes for us. Your assignment, page 736, 12 through 26 even. So here's your assignment. All right, thanks for watching today.